Hello everyone. We're finally excited to share the patch notes for TunaMetaPack 1.4. Since the release of Unreal Engine 5.6, a massive number of things have changed. So we also had to spend a considerable amount of time preparing for this update. Overall, several rigging pipelines have been updated. And in this 1.4 patch, we now support a pipeline that applies the latest rigging setup methods. Because this update took a long time to complete, it comes with a wide variety of new features. So we hope you'll watch until the end. Now, let's start by looking at the update notes for MeshWarp. In MeshWarp version 1.5, we've added support for the DAZ 3D Genesis 9 model to the convertMesh feature. This means you can now convert a Genesis 9 model into a Metahuman LOD0 mesh, and vice versa. Right now, I have a Metahuman LOD0 mesh, so let's try converting it into a Genesis 9 model. Yes, as you can see, the new Genesis 9 model has been successfully generated. The UVs are also properly aligned to match the Genesis 9 layout. If you adjust the maintain offset parameter here, you'll notice slight corrections happening along the seam lines. However, when converting from Metahuman LOD0 mesh to Genesis 9, you might encounter some broken geometry around the fingernail areas. In that case, you'll need to use the Mesh Edit tool in MeshWarp to manually fix those areas. First, make a copy of the base mesh, register it here, and then adjust the offset values on the converted mesh until the problem areas look correct. In my case, since I'm only replacing the fingernail vertices, I don't mind if other parts get slightly distorted. Let's duplicate this mesh. Now, select only the fingernail vertices. We'll create a selection set in MeshWarp using just these selected fingernail vertices. Next, increase the smoothness value. Select the previously duplicated fingernail-only mesh, and click Make Split Target. This will smoothly replace only the fingernail vertices on the base mesh with the ones from the target. Originally, the fingernails were broken like this, but now, with the newly replaced mesh, the issue is resolved. Now let's try the reverse. Imagine you have a Genesis 9 model, and you want to convert it into a Metahuman LOD0 model. You'll probably notice some distortion around the neckline. This can also be adjusted using maintain offset. However, keep in mind that toggling maintain offset can significantly affect the shape of the eyelids. And as you can see, there's some distortion in the chest area as well. Don't worry. You can blend only the specific areas you want using the Mesh Edit tool. Just copy the base mesh, recreate and duplicate the source shape, then blend each area just like before for a smooth result. Also, if you use the vertex set JSON file we've pre-configured, you can easily replace specific parts with minimal effort. We've already explained these MeshWarp features in the past, but they're so useful that we felt it was worth going over them again. Now, let's fast forward the video to show you the final result. Now we've almost perfectly converted it into a Metahuman combined LOD0 mesh. Once everything is finalized, I'll go ahead and delete the original meshes. Next, I'm going to convert this back into a Genesis 9 model. This time, I'll show you how to split the Genesis 9 model into head and body. We've added a Genesis 9 model template to the MeshWarp template library. This model here is the official Genesis 9 template. We'll use the existing split combined mesh feature just as before. First, register the combined template model, then select the cut head or body template mesh first, followed by your own combined character mesh, and then click Split Combined Mesh. Repeat the same process for both head and body. The method is same. As you can see, both head and body are cleanly separated with no seam lines. We already explained this process in detail in the TunaMetaPack 1.3 patch notes, specifically when converting meshes with different topologies such as scan store meshes, and we also covered how to import skinning data afterwards, so we'll skip that part here. That wraps up the Mesh Warp update. Now let's move on to the MetahumanSet. In this update of MetahumanSet, a completely new pipeline has been introduced. It's the pipeline that utilizes body DNA, which is now supported starting from Unreal Engine 5.6. We've decided to refer to this new approach as newest mode. At the same time, the traditional body rig pipeline is still fully supported. We'll refer to that as legacy mode. In this 1.4 patch note, rather than focusing on how to use the newest mode, we'll cover what has been expanded and how the overall pipeline has evolved. That's because we've already released 4 dedicated tutorials that explain the usage and logic behind the newest mode in detail. So if you're curious about how to use it or want to understand the core principles, please check out the newest mode tutorials we've provided. Now, let's take a look at what's new in the MetahumanSet update. In MetahumanSet 2.0, you can now choose between newest mode and legacy mode. Make sure to open your plugin manager and enable the Metahuman for Maya plugin. With this update, we officially support the standard Metahuman for Maya plugin and its associated libraries. If the plugin doesn't activate properly, try deleting or moving your Quixel Megascan library from your Documents folder, then restart Maya and try again. We no longer support the old DNA calibration libraries on the plugin side. You must enable the latest Metahuman for Maya plugin, and make sure all related plugins are activated as well. Now, templates are clearly marked and separated as newest mode and legacy mode. Don't get confused. These are not the same files. They are completely different templates for different pipelines. The folder structure also reflects this separation. Templates for newest mode each include their own body DNA file. Let's try loading one of the template files now. You'll see that the correction joints in the template are no longer connected via RBF nodes, but instead are directly connected to the DNA data. And as you can see, the correction joints still function perfectly. Also, there's now only a single root joint. In newest mode, the root driver joint is no longer used. We also no longer use Pose Wrangler like we did in the old legacy system. You'll notice that there isn't a single RBF Solver node in the scene anymore. Instead, all body poses are now handled entirely through DNA. Since the body DNA in the scene is automatically recognized, clicking Open Ultimate DNA Editor will launch the editor with the DNA data already loaded. In the Behavior tab, you might see some odd-looking rig logic entries. Just ignore those for now. Uncheck the expression box and enable the RBF box. Looks familiar, doesn't it? These are exactly the features you've been waiting for. If you thought the Ultimate DNA Editor only worked for heads, think again. This is truly the ultimate DNA editor. And remember, any modification to DNA happens through this tool. Now let's move over to the Geometry tab. This section contains the core information related to the body DNA. I'll go ahead and set a path for saving a new body DNA file. When you click Break Connection, just like with the head DNA, all connections on the body's corrective joints are severed, allowing you to make edits freely. In this state, existing users can use the tools under Body Settings to reposition joints however they like. Once you're done repositioning, click Save Current Joint Init Data to save the current pose state directly into the DNA as the new initial pose. Now let's head back to the Behavior tab. Modifying pose logic here works exactly the same way as it does with facial logic. After clicking Break Connection, make all the edits you need. Then click Save Current Joint Edit Data to save the current pose setup into the DNA. If you want to mirror, just use the Mirror Logic function. It's no different from how you did it when editing facial logic. This time, let's take things a bit further. I'm going to mirror multiple pose logics at once. Starting from Ultimate DNA Editor 2.0, you can now select multiple rig logics at once. Multi-selection is supported for batch mirroring. This means you can selectively pick only the poses you want and mirror them in one go. Just note that when mirroring, it's best if your character's body joints are properly mirrored and symmetrical. This ensures the mirrored results come out correctly. One more feature that's been added is the set weight logic function. When you select a rig logic item and choose the joints you want, clicking Set Weight Logic will allow you to adjust the current pose using weight sliders. Then, you can simply hit Save Weight Logic Data to store it directly into the DNA. Let me show you again. With a rig logic item selected, choose the joints you want, click Set Weight Logic, and a weight controller will be generated for that pose. You can fine-tune the movement of that pose as much as you'd like and save it when you're satisfied. It feels very similar to the previous legacy pipeline, doesn't it? This feature is useful not just for body logic, but also when editing facial rig logic. Now, let's briefly go over how the head connection works. In newest mode, the way you connect the head is a bit different. In legacy mode, we use the Connect Head Joint button. You'd bring the head rig into the current scene, and then press that button to automatically connect the head joints to the body joints. But in newest mode, you don't follow that approach. Instead, you directly import the head rig Maya file itself. That means you don't pre-import the head rig into the scene manually. Also, the head rig must come from the character assembler, not from the DNA viewer. Only head rigs imported this way can be properly merged with the body. Using Maya's regular import function won't work correctly. The head rig brought in this way doesn't have separate head joints. It's already merged as a child hierarchy under the body's root joint. So, no additional head-to-body connections are needed anymore. However, the skinning for the head mesh still needs to be reapplied. Otherwise, you'll get visible skinning gaps between the body and the head. That's why it's essential to use MetahumanSet's Auto Skin Load feature to reapply the skinning to all head LODs and ensure a seamless connection. Now let's take a look at what has changed in the export phase. As you can see in the newest pipeline, there is only one root joint, and there are no separate head joints. However, when exporting either the head or the body, you must make sure that only the joints relevant to that part are included in the hierarchy. That's exactly why we've prepared the Rig Manager. Inside your document's TunaRig, Tools JSON_files folder, you'll find a collection of pre-configured Rig Manager sets ready to use. Here, users can apply whichever hierarchy set they need. Each set contains a predefined virtual joint structure, and when applied, your actual scene objects will be reorganized to match that structure. We provide default hierarchy sets designed for default setup, body export, and head export set for it. These are included as default templates. Once you select all the items included in a hierarchy set and click Apply Rig Hierarchy, the scene will automatically restructure the selected objects to match that export target. Since the Rig Manager reconstructs the hierarchy exactly as listed, this makes it incredibly easy to separate head and body setups for export. Once this structure is applied, you simply select the LOD mesh group and root joint, selecting the full hierarchy, and export from there. It's the same process for the body. Once you select and apply everything in the body export set, only the joints required for the body will remain in the hierarchy, making the export process much cleaner and more efficient. Once your rig hierarchy has been changed using the Rig Manager, you can now simply select the root joint and LOD mesh group, make sure to select the entire hierarchy, and proceed with the export. But always remember, the exported root joint must be the outermost node in the hierarchy. If you ever want to revert the hierarchy back to its original state, just reapply the original rig set using the same Rig Manager process. Also, if you want to add your own custom hierarchy set to the Rig Manager, you absolutely can. For that, please refer to the dedicated tutorial we've created. We walk you through exactly how to create and manage your own hierarchy sets. That wraps up the main update for MetahumanSet. Now, let me briefly mention an update to Tuna utils as well. When you bring your character into the scene via Characator Assembler, you may notice some issues, such as locked normals or incorrect neckline shading. In those cases, you'll need to replace the shapes using the LOD meshes you created earlier. But going through each LOD mesh one by one and using the change shape function manually is time-consuming and tedious. That's where the powerful new feature comes in. Auto-match selected mesh to all scene mesh in the Metahuman Utils tab. This function searches the scene for all meshes with the same vertex IDs as the meshes you selected, and replaces them all at once with the selected meshes. After the replacement, you'll get a message saying the old meshes have been saved as backup meshes, and it's now safe to delete the source meshes. Since I don't need the backups, I'll delete them now. Let's take a look at the LOD0 body and head meshes. As you can see, the seam line is completely gone. All the meshes have been perfectly replaced with the ones we made earlier using Mesh Warp. This tool is incredibly powerful, so be sure to take full advantage of it in your workflow. Great. Now for the final part. Let's wrap up by sharing the latest updates to the Ultimate DNA Editor. As you saw earlier, during the overview of the MetahumanSet, the Ultimate DNA Editor now fully supports body DNA, along with newly added features like weight logic and multi-mirror logic. However, there are two critically important features added to Ultimate DNA Editor 2.0 that were not covered in any of the 4 tutorials we previously released on the newest pipeline. So, let's take a look at the 2 major additions in the Ultimate DNA Editor 2.0 update. Before we get into the newly added features, let me share this one thing first. The DNA files you're using are now categorized and managed by their version names. From now on, only DNA files with the DHI or MH.4 version can be opened through the DNA viewer. Starting from version MH.6, DNA files can only be opened through the Characator Assembler. Also, when you open a DNA file, you'll now see its version information displayed in the DNA info section. Now then, let's dive into the new features. There are many cases where you might want to modify rig logic using blend shapes. For demonstration purposes, I'll exaggerate the shape a bit by applying a blend shape. Have you ever thought something like this? I wish this shape could be reproduced exactly using joints instead. In other words, you want the shape to be represented reasonably well using joints alone, even without the blend shape being applied. This is especially important because after you finish rigging, you might want to attach things like beard or other accessories to the face surface. However, when using blend shapes, such attachments become quite limited. To address this, we've added a new tool in this update called the ML Joint Match tool, which uses machine learning to automatically reposition joints based on the shape. This feature is actually officially supported by Epic Games in the expression editor within Metahuman for Maya. We analyzed the machine learning model used in Epic Games' expression editor and adapted it, so the same functionality can now be used within the Ultimate DNA Editor. So now, you can freely use this functionality right inside the Ultimate DNA Editor. Using it is very simple. With the desired blend shape applied, select the rig logic item you want, and then click the Match Joint button. A prompt will appear informing you that once the matching process is complete, the DNA will automatically be saved to the current output path and reloaded. Let's click Yes. The first time you run this, it might take a bit of time since it needs to load the machine-learned model. But from the second time on, it should be much faster. Oh, now the computation has started. Can you see how the joint positions have changed? Let's save the result. Unlike before, the joints now clearly follow the shape. The shape matches the morph target exactly. How is this possible? If we turn off the blend shape, we can still see that the shape has been matched to a fairly similar form, even without the blend shape being applied. So what you're seeing right now is the shape after the joints have been matched, and the blend shape has been applied once again. It came out really naturally, didn't it? As you can see here, most areas are nearly aligned, but only the region around the eyes shows a significantly greater discrepancy between the blend shape and joint skin. Even when using ML Match Joint, Such severe separation in specific areas occurs because the rig logic only operates within the predefined joints assigned to each region. In other words, if the logic you're editing, like mouth corner pull left, doesn't include any joints related to the eye, then even with machine learning, the eye joint won't be matched. These kinds of issues are inevitable, which is why it's important to identify the overlapping influence areas for each rig logic in advance using joint boundaries. Now, let's try editing the mouth right logic using the same method. I'll duplicate this mesh, and this time, I'll only modify the mouth area, making sure not to affect the eye region. There, I've completely changed the shape. The mouth is now positioned much lower than before. Let me rename this and then apply the blend shape. Now, let's run the match joint process again. This time, the model loading process is skipped, and it proceeds straight to calculation. If you've loaded the ML model even once through the Ultimate DNA editor, it will apply this quickly from then on. All right, it's done. You can clearly see that the joint movement differs between the left and right sides. Even with the blend shape turned off, the error is negligible. It's applied very well. As mentioned earlier, this feature is nearly identical to the Run ML joint matching function in Epic Games' Metahuman Expression Editor. I'd like to emphasize once again that thanks to Epic Games' ML model, you're able to make these modifications so freely. Once these changes are made, using mirror logic will apply based on joints, making the workflow very convenient. However, there's one important thing you need to remember. The ML joint match feature only works with DNA version MH.4 or higher. It does not work with older DNA versions such as DHI. So make sure to check your DNA version beforehand. Now, with that in mind, let me share one more new feature with you. In this scene, I've loaded a very early version of DNA, the DHI version, one of the original formats. As you can see, when this old DHI DNA is brought into the DNA editor, the version is displayed as DHI. Unlike MH.6, the DHI version doesn't even include the RBF section. This is from the very old DNA format, which had all 734 logic entries. Most of the DNA files you've previously created will either be this DHI version or MH.4. So, the new feature I'm going to introduce now is the version change function. The expression editor inside MetaHuman for Maya also has a tool called version upgrade. It's this one right here. However, the functionality it provides is quite limited. It can only upgrade MH.4, which is the version used in Unreal 5.5, to MH.6. No other versions are supported. In other words, DNA files you created in the older DHI format cannot be upgraded using that tool. So now, let's go to the menu in DNA Editor and click Upgrade DNA Version. A window will pop up, similar to the one in the Version Upgrade tool. Here you can choose a source DNA, which is the version you want to convert from, and a target DNA, which is the one you want to convert to. For the source DNA, I'll select any DNA file from the latest MH.6 version. Let's choose the AdaMH.6 version DNA. Now for the target DNA, I'll select the cartoon characters DNA, which is in the DHI format. Then under the version change section on the right, you'll see that it says the DHI version will be upgraded to MH.6. In other words, I'm converting my cartoon character's very old DHI version DNA into the latest MH.6 version. Now let's specify the output path where the final converted DNA will be saved. I'll choose to save the new DNA inside the MH.6 folder. All right, now let's click the Upgrade Target DNA button. By the way, you can use this Upgrade DNA version tool at any time, even if there's no headrig file currently open in the scene. All right, it looks like it's done. Let's open the actual folder and check the result. Yes, it's been successfully created. Now I'll go to the Ada template folder and overwrite the existing head DNA file with the one we just generated. I'll rename it to head.dna, since that's the required name for the character assembler to recognize it. All right, let's open the character assembler again and try loading only the head. Here it is, successfully loaded. However, it seems like the vertex normals from Ada are still being applied. I'll quickly load the LOD meshes as a reference and replace them. Now, let's load this DNA file into the DNA editor. As you can see here, it's now marked as mh.6, which means this DNA has been fully converted to the mh.6 version. Let me briefly explain what kind of data has been applied. First of all behavior data has been preserved, including joint movements and BlendShape deltas. You can see that the facial expressions are still intact. Even the edited BlendShape data has been fully converted. This works by comparing the rig logic names from mh.6 with those from the DHI version and applying data only when the names match. So, if you had created custom PSD logic in the past, that part will not be applied automatically. As for the animated map data, all existing values are carried over completely. And of course, all LOD mesh data in the Geometry tab, along with the initial transforms of every joint, have also been transferred. This version change algorithm was not based on Epic Games features. Unlike ML Joint Match, it's a completely new developed feature by TunaRig from scratch. That's why version conversion can be performed regardless of the version difference between the source and target DNA files. In other words, conversion is possible not only from lower versions to higher ones, but also from higher versions to lower ones. All right, that concludes the update information for the Ultimate DNA Editor. Now, let me briefly share the update details for the Metahuman AutoSet tool. With the introduction of Unreal Engine 5.6, a new rigging method using body DNA, also known as the newest-based rigging, has been introduced. If you've exported your skeletal mesh using this method, you should not use the original Metahuman AutoSet tool. Instead, you must use the Metahuman AutoSet newest tool. When it says check template here, it doesn't refer to a template provided by us. Rather, if you have assembled even a single MetaHuman character using Unreal's Metahuman Creator, a message will appear saying that a template exists. To reiterate, in your Unreal project, you must install the Metahuman Creator plugin and assemble at least one MetaHuman character. Only then will the latest MetaHuman template be installed under the MetaHuman Common folder. We've created a detailed tutorial explaining this process thoroughly, so please make sure to check it out. Aside from the template-related requirements, nothing major has changed. You simply need to type the body and head DNA file path and provide the character blueprint that includes both the body and head skeletal mesh. And that's all there is to it. However, now that the body also uses DNA, there is no longer a need to create separate pose assets, which also means there's no need to create separate RBF pose animations. Additionally, both the head and body now use the shared post-process animation blueprint located in the Metahuman Common folder. So there's no need to create a separate post-process asset for each character. Also, even if you created your Metahuman using the Metahuman AutoSet newest tool, you must still manually assign the DNA file once more to both the head and body skeletal meshes individually. We provide a detailed explanation of this process through our tutorial, so please make sure to check it out. This newest rig is significantly different from the previous legacy pipeline and represents the most up-to-date MetaHuman rigging system compatible with the latest DNA files. The rigging structure itself has also been greatly streamlined. So we strongly encourage you not to rely solely on the legacy method, but to take the time to learn the newest approach through our tutorial. That concludes all the update information. This wraps up the TunaMetaPack 1.4 patch notes. It was quite a lengthy update. As long as this video turned out to be, it reflects just how much time and effort we put into preparing this release. It was truly a massive undertaking. This update involved introducing an entirely new pipeline, and although it was a tough process for us, we hope it gives you, the users, an opportunity to learn and adopt this new method, develop your own personal workflow, and breathe more individuality into your characters. We will continue to provide ongoing support. Of course, updates may take time, but trust us, we're really serious for metahumans. Thank you so much for sticking with us through this long update. See you next time.